I cannot always use this very basic workflow since I have special setups. I have cluster configurations in place. I maybe want to integrate VMware snapshots, other stuff, or I want to combine workflows. For example, in a maintenance window on the weekend, I directly want to patch the HANA database, the HANA client, the operating systems, and the kernel just in one single workflow. So all this is possible in automatics with our custom workflow engine. This can be found at the configuration custom workflows, and basically splits into two main areas. One is called tasks. So basically a task is the low-level step in an automation process. So in the end, this is a script which can be Bash, PowerShell, or also Ansible playbook. And this is available for different things. So you can fully create your own scripts, but we also provide templates from our side, from automatics, which are good to use in a lot of scenarios, but which can be adopted to the customer's specific needs. So for example, for OS patching, we have tasks already. This is the wrong, sorry for this. I have to go here. In the practice guidelines, we have a lot of, almost ready to use tasks, which just need small adoptions in some cases, not in all cases. And then you can handle all the activities needed. For example, cluster related activities with maintenance mode or service IP related things. I just go through this very quickly. Interesting also is, for example, the whole OS patching things. So we provide templates for Linux patching, for Windows patching, with or without SCCM, etc. Pacemaker related tasks, reboot of hosts, for example. Different tasks for SAP deployment also, for example, to set up systems, set up new systems. HANA system replication is a very important topic here. And finally down to the Windows failover cluster. So for all these integrations, there are templates available from our side which can be used. And these tasks are then combined together in custom workflows. So a workflow is a combination of tasks which can be created very easy. So let me quickly show you how to create a new custom workflow. I can call this Tricise webinar. I can choose an icon, I can give a description, I can categorize and group workflows, and I can select on which entity level I want to execute this workflow. So do I want to execute it for whole systems, for single components only, or maybe on a host or so on a node level? Let's say I want to do it for whole systems. And what I want to do is defined in the steps. And I can here make a combination of single tasks, of other workflows, for example, all together, automatics provided steps and workflows, and also customized or customer created things. So I can, for example, say, let's make a kernel change from file share. And after the kernel change, let's do a HANA server update from a file share. And after that, even a HANA client update from a file share. So here I can really combine these automatics workflows into one single customized workflow. And then let's say I also want to do a snapshot. So I know there is a task for this where I can create a VMware snapshot. Not NetApp, VM snapshot create. And let's say, of course, it makes sense to do the snapshot on the first step. So I just can move this around here and say, okay, make the snapshot, make the kernel change, change the HANA server and also the HANA client. Now I can just save this workflow, and after that, it's immediately ready to use. So I can then go to automation, and beside the automatics standard workflows, I here have the tab for custom workflows. And now somewhere I have not added the group, and I have to reload the page once. I should then see the Tricise. I have disabled the section, sorry. So it's in the default section if I do not define a group. And now I see this Tricise webinar. And when I go into it, it's again the same wizard. I select the systems where I want to perform this workflow. Next, some configuration. Now a bit more, since it's a combination of a lot of stuff to do, but yeah, very easy to understand and to use in this wizard, and then I can directly execute. Yes, that's basically how the custom workflow mechanism, the custom workflow engine works in automatics. I just want to give you 2 or 3 more examples of what can be done and how does this look like, especially for zero downtime things. So I've prepared and executed some workflows. One, for example, is operating system patching for a high available NetWeaver system. Hard to say. In that case, with a non-clustered ERS, so the older setup, for newer setups, of course, the ERS is also clustered. This basically works the same. So this is just one of our test systems where we have this non-clustered ERS. And when I jump into this execution, I now see the whole process that's happening there. So at the beginning, automatics is collecting some information. This is not so interesting. Then the interesting part really starts here, where automatics stops the ERS. So the application server, this is a dual application server system where it stops the application server on the ERS node. This is done in a sub workflow, so workflows can be cascaded, and I can directly jump into the logs and the execution details of this sub workflow by clicking on it. And here I just see the instant stop of this application server with instance number 31. So this was stopped within this workflow. Once the application server is stopped, in the next step, the ERS is stopped. Again, the same within a sub workflow. And then on this node, which now has no running ERP, no running SAP instance, the OS patching and the reboot is done. Maybe let's quickly look into the logs here, what this looks like. Here is also some of the cluster stuff happening. So in this case, we choose the way to directly interact with the Windows failover cluster. There are often several methods how this can be done. For this execution, we suspended the cluster node and trained the roles. So we really make sure that there is no running cluster resource on this node. Yeah, looks just like this from the output. Then we ensure all cluster operations are finished, and then we directly do the OS patching and the reboot. So in this case, as you can see, some of you may know how Ansible output looks like. So this is an Ansible playbook for the OS patching. And in this case, one security intelligence update was installed on this Microsoft server. Yeah, then the host is rebooted and it is waited until it is online again. And after that, the Windows failover cluster is set to resume the node and fail back the roles. So it is back to the former operational state again. And now in the main workflow, once this has finished, the ERS and the application server are started again, this needs to be done separately since it is not part of the cluster. So there are no cluster roles for the application server and the ERS in that case. If the ERS is a clustered instance, which is more often the case in modern setups, then the stopping and starting is done during the cluster node standby. And once everything is up again on this node, the same thing again happens on the other node. So the application server is stopped, and then the OS patching with this cluster suspend and resume is triggered, which then automatically moves the ASCS instance to the other node so that the system really is online all the time during this whole process. So this is really a zero downtime OS patching workflow, which automatics fully handles automatically. One more example for HANA patching with zero downtime with system replication setup. In this case, there is a pacemaker in place on this system, but we decided to not use the pacemaker for the switchover in that case, just for demonstration purposes, but we did the switchover directly with automatics. So again, after collecting some information, here the main workflow starts. We just quickly check if everything is fine with the system replication. And then we start with HANA server patching on the secondary side. Just once again, a quick look into the HANA patching process. So here we have the whole log output of the HANA lifecycle management. So here really the HANA server component was patched. And then the operating system is patched on the secondary side. And then it is started again. And after the start, there is a HANA takeover is performed, which consists of several steps. Now with automatics really performing the takeover. So doing all the necessary commands like bringing down the service IP, stopping the tier, performing the takeover command itself, and bringing up the service IP on the other side so that the database is reachable again. And then the former primary node is now free of any relevant resources, and the HANA and OS patch can be done there. And after that, just to bring the HANA system replication setup fully online again, we register the former primary side as a secondary and start the database again. And finally, verify if everything is fine with the system replication. This is an example for a HANA database. And one last example how all this can be combined during the whole stack. So in this execution, we really did operating system, database, and database client and kernel patch in one single workflow. So also this is possible to combine it through the whole stack. Just very quick. It started with some validations, then the SAP components are stopped. So in this case, it is not zero downtime. This is a patching process with downtime, but it demonstrates how a maintenance window on the weekend during nights can be done without any manual interaction through the whole stack. So the components are stopped. Then the HANA database server is patched. This again is a sub workflow. Then the HANA client is patched. So here we have the log output of the lifecycle manager patching the HANA client. Then we do the whole kernel change. A lot of log output here for the kernel change. And finally, we also do an operating system patch. As you can see, also a lot of S packages have been installed on this system, haven't been patched for a long time. And then basically we are done and we start. Also a reboot can be added here. So in this case, we did not add the reboot, but it can be added at any time. And after the reboot, then all components and services can be started again. Yeah, this was one more example. Finally, before I finish my live demo, I just want to show you something from a very recent customer scenarios, since I really like this project at the customer side. So I'm sorry for the German words. The customer is an Austrian customer, and he wanted everything in German, also the names and the descriptions. But what this means is update operating system for a HANA DB and the SAP system. And when I jump into this, we see how the customer provided this workflow, which steps the customer added to this workflow. This is a former SAP landscape management LaMa customer. So he always does full unprepare and prepare of systems. So with removing all the mounts, removing all the virtual IP addresses, etc. So instead of a normal stop or start, here we always talk about unprepare and prepare. And what's also interesting here is the VMware snapshot integration. So before the OS update is done, a snapshot is created. And after the snapshot, there is another integration to VMware to upgrade the virtual machines hardware. So this is also done directly during this process. If there is a newer VM hardware version for this virtual machine, this is also deployed at this point. And also very interesting for this customer, it was very important to have a safety mechanism, especially for production systems. If something is wrong or something goes wrong during the operating system update, for example, or if the system is not coming up again after the update, that there is always a quick way back and an automatic way back. So they trigger or they schedule the production updates during the nights at 1, 2 o'clock in the morning. And if something goes wrong, there is an error handler defined. So this is also possible, which basically reverts the snapshot and then prepares the system again. So that if something goes wrong in the morning, the system is back online again with the old state. And then the SAP Basis administrators can go through the logs and check what's going wrong, correct maybe the things relevant, and then trigger this update again for the next day.